Okay, in this section, we're going to be talking about writing the new equation given the verbal description now. So this is a little bit different than before. I mean, we're still kind of doing the same thing, but we've basically been given the operations and what's happening to our equation before, whereas now we need to recognize what the verbal transformation means when we are actually writing our new equation. Okay, so now that we've had some practice with the function notation, we're just going to be given the verbal transformation and have to come up with a new equation that way. Okay, so again, it gives us an equation to start with, 3x plus 2. And then it has a couple transformations that it wants me to do here. So first thing, let's do the one that just says 1. So a horizontal shift to the right 4. Remember, guys, when we talk about horizontal transformations, we just want to put those basically where the x's in parentheses, right? So especially with linear, it just goes in there and then we're basically done, right? The question is what kind of operation are we going to use? So horizontal transformation, remember, this is again where we get confused because it's the opposite way you think. If it's going to the right, you're actually going to subtract, okay? So if it's going to the right, my new equation is going to become 3 to the x minus 4, or 3 times x minus 4, sorry. We're not 2 though, that's the next one. Okay, 3 times x minus 4, and then there's nothing happening outside the or vertically, so that plus 2 is still there. So again, for me, this is kind of all I want you to do. Once you get to this point, you can stop. Okay? If you have Miss Nebeker, she may want you to distribute and then combine. Um, you're like, oh, I'm going to talk to her, see if I can convince her to stop right there. Anyway, next, let's do one that has 2. So I have a vertical shift up 3 and then a horizontal shift to the left 2. So again, since we subtracted when we went right, that means you're going to add when you go left. So it's going to be 3 times x plus 2. Okay, then a vertical shift up 3. That means vertical shifts happen at the end of your equation, right? So vertical shift up 3, it's going to go to the end, and if it's up, you're going to add just like you normally would. So I have plus 2 plus 3, and then I can simplify that. The 2 and 3 are going to become combined to become, oops, yeah, 5. So there's your final answer there. Okay, exponential. I like exponential a bit more because I don't feel like you lose your horizontal transformation if you distribute, but you don't really lose it if you combine like terms with exponential. Okay, so let's look at the exponential equation as 3 to the x minus 5 plus 2. So it wants me to do a horizontal shift to the left 6. So like I just said, if we go to the left, you're going to end up adding. So when we set it up, it'd be like 3 to the x plus 6. And I'll put that in parentheses, and they're just going to drop. Minus 5, and then that plus 2. And then I can simplify that positive 6 and that negative 5 are going to combine to become just positive 1. So my final equation is going to be 3 to the x plus 1, and then plus 2. That's not part of the x. Okay. And then the last one in this section, basically, a vertical shift down 5 and a horizontal shift to the right 2. So right 2 means you're going to be subtracting in your exponent. So it'll be 3 to the x minus 2. And then I still have that minus 5 up there. And then I have a plus 2 to begin with, and then it wants me to go down 5, which means I'm going to subtract 5. And then when I simplify this, negative 2, negative 5 are going to become x minus 7. And then 2 and negative 5 are going to become negative 3. So minus 3, not part of the exponent. Okay, and that's really all you're doing in this section. Again, just rewriting the equation, recognizing what the verbal transformation means, and using that to add in the appropriate operations into the new